Okay, so this will be the actual physiology of the digestive system. I'm going to try to do all the slides 17 through 23 on this, but if we get around 10 minutes, I may stop it and do a second one. So this will be the route that food takes as it passes through the digestive system. And starts with the eyes and the nose. The eyes and the nose are really the first organs of the digestive system. And because they help to cause us to release the enzymes and the saliva, which we'll talk about when we talk about the cephalic response. The mouth is where we begin digestion because the mouth has the mechanical mastication, or the chewing, where the teeth are grinding up food into the smaller particles. And the tongue's function is just really to move the food around in our mouth. Saliva helps bind the food together into this bolus, and the tongue also helps form that bolus. That bolus is just that ball of food that we're going to swallow. Chemically, we have the salivary amylase, which we've already talked about, which helps us digest carbohydrates. And then sodium bicarbonate. Remember, the sodium bicarbonate helps reduce acid, because we don't want to have too much acid on our teeth. The pharynx is where we're actually going to swallow the bolus. So the three stages of swallowing are formation of the bolus, and that happens with the tongue and the teeth forming that ball of food that we're going to swallow. And then the bolus actually gets forced into the pharynx. So we force this into the pharynx. The next thing that's going to happen is we're going to swallow that. And to swallow it, the soft palate raises up and blocks the nasopharyngeal cavity. And then the larynx also becomes elevated during swallowing. When it elevates, the epiglottis closes. One of the reasons why we shouldn't breathe in too much, or at all, when we're swallowing food is that when we breathe in, that larynx will lower again and the epiglottis will open, and we can get food into the larynx. Tongue closes off the oropharyngeal cavity, and the pharynx comes up to receive the food. The esophagus opens and the food gets forced into there. And then the third part, or the third stage of swallowing, is just the peristalsis, where the food, smooth muscle, forces food down the esophagus. So those are the three stages of swallowing. The stomach, once the food passes through the esophagus, is going to arrive in the stomach. And in the stomach, we have mechanical and chemical digestion again. We have mechanical digestion with just the fact that the muscles, those three layers of smooth muscle, are twisting and turning and helping to crush the food together. There's the liquid in the stomach, and that liquid helps the food to separate And then the mucus cells do the same thing. So we have mucus cells in there that help us separate those food particles. We have the chemical digestion part of the stomach. Parietal cells, the parietal cells produce hydrochloric acid. So these are producing the hydrochloric acid. So that's our stomach acid. They also produce an intrinsic factor, which doesn't really come into play till later on when we want to absorb B12 in the small intestine. So that's what the intrinsic factor is for. The hydrochloric acid helps to break apart the bonds that are holding the food together. Parietal cells are inhibited by somatostatin. Remember that hormone, somatostatin. So they're inhibited by that. The parasympathetic nervous system is what inhibits somatostatin release. So our parasympathetic nervous system, when we want to digest food, will inhibit somatostatin release. And it also stimulates these chief cells. Well, the chief cells, the mucus cells, and the parietal cells. So the parasympathetic nervous system is stimulating all of those. The chief cells produce pepsinogen, which is an inactive enzyme. So pepsinogen is an inactive enzyme. When pepsinogen mixes with the hydrochloric acid from the parietal cells, it becomes an activated pepsin enzyme. Okay, and then the pepsin is used to break up proteins. Pepsin is one of the few enzymes that don't end with A's, by the way. What we form here is chyme. So chyme is all that digestive food that we ate, along with the fluid in the stomach and all those hormones. So that chyme is that brownish fluid that we'll throw up sometimes if we get sick. In the stomach, there is some absorption also. Water is absorbed in the stomach. Salts are absorbed in the stomach. And alcohol. This is alcohol. Alcohol is absorbed in the stomach. Remember, the stomach is producing a lot of acid. I mean, in a very low pH acid. So the stomach is constantly producing a mucus from those mucus cells to protect the stomach walls. Otherwise, we would actually eat our stomach away with the acid. Sometimes we get a bacterial infection in our stomach, and it can actually cause those mucus layers to break down, and then we get injuries to the stomach wall from the acid. There's 3 phases of gastric secretion. So this is when our stomach will produce the enzymes and the acid that we need. The 3 phases are in order of when they occur. So the first one is the cephalic phase, and this one happens when we smell, see, or even think about about food, the cephalic region. So this is a parasympathetic nervous response to the food stimuli. This will cause stomach acid to be produced. It'll cause saliva to be produced. It's what gets everything moving. The gastric phase is when the stomach releases the gastrin in response to food just being in the stomach. So when we get food in the stomach, we release that gastrin. And then the intestinal phase is when food moves into the the chyme moves into the stomach, into the small intestine, due to the increased juice or gastric juice from the presence in the stomach. So those are the three phases of gastric secretion. So I'm going to stop this now, and then we'll pick up with slide 21.